Okay, class, this is the last part of chapter 2. So previously we talked about electric current and then potential difference and resistance. There's actually everything in Ohm's law. One thing that I forgot to mention that is a series and parallel. Okay, so you know that series look like this. This is like revision for your this one you learn it in your form 3, right? So if this is R1, this is R2, and this is R3, let's say now I think you can understand better why is it series has its formula as R equal to R1 plus R2 plus R3. Okay, let's say this is Roderick 1, Roderick 2, and Roderick 3 that disturb when Jasper and Casper walking around. So the total disturbance will be R1 plus R2 plus R3, right? So what is electric current? Do you remember electric current is the number of charge flowing through, right? So now we have only Casper and Jasper. So all the way here, all the way the path that in the loops here, series circuit, we have only two person, that is Jasper and Casper. So it won't change. So the current here will be equal to I1, equal to I2, equal to I3, because there's no other way for them to move around. So what is voltage? Voltage is energy, right? If you still remember, it's a breakfast that taken by Jasper or Casper. So the energy that needed to move from A to B to C to D will be equal to, let's say this one is V1, this one is V2, and this is V3. Okay, so you know that the total energy that needed to travel from A to B will be equal to the total energy that you travel from A to B, B to C, C to D, right? So you have to sum out everything, V1 plus V2 plus V3. So now it looks so easier for you to understand why is it we have this formula in series circuit. And how is it we have to connect our ammeter and voltmeter? Since that we said electric current is the number of charge flowing through, imagine it's the number of students walking through. So we have to be in the circuit. Okay, so I have to connect my ammeter here so that I can calculate, one Jasper go through, one Casper go through, one Bernard go through, one Kevin go through, like that. Okay, so I have to be in the circuit itself. Okay, but then potential difference, voltage is energy from one point to another point, right? So I must have connected two different points. That's why voltmeter never connect it in, you never connect voltmeter in the circuit itself. It must be coming out. It must be something that outside from the circuit. Then only you can judge from one point to another point. So I hope that you understand why is it. This is the way that we connect ammeter and voltmeter from your definition. This one always parallel. Okay, this one always series. Okay, so now we go to parallel circuit. Okay, so parallel circuit like this. Okay, so now you have to imagine you have two. Let's say now we have three person that moving in, Jasper, Casper, and Roderick. So Jasper will come here, Casper will come here, Roderick will come here, right? So your current will be the total current here, total current is 3, let's say. So will be equal to I1 plus I2 plus I3 because you have cabang, you have branches here. When you come to junction, okay, one come here to continue to move, another come here, another one will continue to move. That's why we have formula I1 equal to, I equal to I1 plus I2 plus I3. And potential difference is from one point to another point, one point to another point, one point to another point. So you can see that actually it's the same. Okay, so V will be equal to V1 plus equal to V2 equal to V3. So the only difference here is resistance, because Ohm's law, you know that resistance always bottom, right? So it is R1 plus R1 per R2 plus 1 per R3. This is basically a revision from your PT3 syllabus, right? Okay, and then we have to continue to the last part of this chapter, that is electrical energy, electrical power, and efficiency. Okay, this one normally I would just use 5 minutes to cover everything because it's like formula. It's very easy. Just that when it comes to calculation, a bit headache. Never mind, we will settle this calculation when we meet later on. But theory-wise, I will still have to explain. So what is energy? Energy, right? The unit is actually joule. And then power, the unit is watt, right? Okay, so we learned in Form 3, we said that power equal to energy divided by time. So watt equal to joule per second. Okay, so that is what we call energy. Okay, and then here for this chapter, you have to only remember two formula, that is energy and power. Power equal to IV. Energy equal to VIT. Okay, so how you got this formula? Okay, you know that power equal to energy divided by time, right? So energy will be equal to power times time. So what is power? Power is actually current times voltage. So will be equal to IVT. IVT, I don't think that it sounds nice, so I always pronounce it as VT. So energy is actually VT. Okay, why is it you said that power is current times voltage? You still remember Kevin said what kills? Current contribute, voltage also contribute. Actually, theoretically, Kevin was right. Okay, so when we buy light bulb, we normally look at the watt, right? The power of the light bulb. Let's say you buy 20 watt or you buy 100 watt. So which one is brighter? 100 watt is brighter than 20 watt, right? So this is the power. So power is actually determined by current and voltage. So there are only two formula that I want you to remember. That is P equal to IV, energy equal to VIT. Okay, and then what is efficiency? Last thing in this chapter. Efficiency is the output energy divided by input energy times 100%. Let's say I have a light bulb here. Okay, I supply energy, let's say I supply 100 joule. Somehow I get only 80 joule of light, the brightness. Okay, so it means that it is not 100% energy. It always not 100% energy because it was somehow the energy will change to heat energy and so on. So we have always a wastage of energy. So you have to remember this formula, and efficiency. Okay, so it look very easy, right? So class, I know that there are many YouTube video that online you can actually go for it if you want to understand further, but this is the syllabus that you have to know. Okay, I'm going to give a test after school reopen. This is definition test that we always had in class, remember? Okay, electric current. What is electric current? I hope that you remember. What is potential difference? Is PD, and then the unit is voltage, right? And then EMF, electromotive force, the unit also voltage, right? Resistance, ohm. Internal resistance also ohm. Okay, Ohm's law. This is Ohm's law. Current is directly proportional to potential difference. 4 factors affecting resistance, we have 4. Ohmic conductor is a conductor that obeys Ohm's law. Non-ohmic conductor is a conductor that does not obey Ohm's law. Okay, I forgot. We have series and parallel here. Okay, series and parallel here. For this one, I want you to only draw the circuit and then do simple calculation. Okay, then what is superconductor? Did I explain this? I think I missed out this superconductor. So superconductor means that you have zero resistance when it is below certain temperature. Normally it is very cold. Let's see. Superconductor here. Okay, sorry I missed out this. So what is superconductor? Superconductor is the conductor with zero resistance when the temperature is lower than critical temperature. Okay, so every material or every metal, it has its own critical temperature. For example, zinc, you have 0.88 Kelvin, means that when the temperature is lower than 0.88 Kelvin, the resistance in zinc will be 0, which we love it a lot, right? Because you don't want resistance, you want superconductor so that you have supercomputer and then you can play your games, right? Okay, that's all. Superconductor, only one word, is a conductor with zero resistance when the temperature is lower than critical temperature. Okay, this one we learned just now. Electrical energy, power efficiency, and then cost calculation. This one you learned in Form 3, right? If you still remember. Okay, so cost calculation, we know that 1 unit equal to 1 kilowatt hour. This one, never mind. I think you almost forget everything. We will do calculation again after school reopen. Okay, these are basically everything that you have to remember. Make sure that all the definition is in your brain. Well, I'm going to give you a test after school reopen. Okay. One more thing I want to remind, on Monday 10 a.m. we are going to have online class. So Zoom, we are going to use Zoom. Make sure that you install Zoom, and then I will give Samantha the link. Please click in and join my class. There will be very short class, don't worry class. Well, I estimate only have 1 hour like that. We can discuss over what is the question that you are having, and I want to know how's your progress so far. Okay, thank you class. Darren, make sure you are here, and then make sure that you shout to the class, good morning teacher. Okay, thank you class.